My name is Matt Reynolds. I'm an NXCAM applications engineer, and today we're going to be covering something called the master model technique and how this technique can be used in the manufacturing context to save time in programming and simplify file management. We're going to have slides along with a brief NX demo. We're going to hop back and forth, and this presentation is meant to be sort of seen as a guide for best practices, and we'll be showing specific examples of how we use this technique here at Applied to our advantage. So this is just sort of a guide. There's more than one way to approach master modeling, and we're going to show you one example. This presentation will aim to cover one technique and one tool, and we'll show how using them in combination will have benefits to CAM programming. We're going to start by covering the master model technique and its benefits, and then we'll cover the wave linker. So the technique, we're going to learn about master modeling, the tool, wave linking. Along the way, we're going to show some examples of exactly what we're talking about. And again, this is a guide to a best practices approach to master modeling in manufacturing. So these are our rough presentation goals. If you've heard of any of these things before, here's a more specific version of what we're going to actually be doing. We're going to be covering what amount of master modeling is right for you, how you can use WaveLinker to set that up. We'll be covering the file structure, explicitly what to call your files and how to organize them. And we'll show how using these things all together can help you speed up CAM programming. So let's start with the first and most important question. What is a master model? So on screen, we have the official Siemens definition of the master model concept. And so I'm going to read a little bit. But a master model is essentially a file that is the sole component of an assembly that contains data that reaches across multiple applications. So one example might be that you have a CAD part file, like a 3D solid body, and that 3D solid body informs the drafting application. You make drawings from it. It informs the manufacturing application. You use that part file to write CAM programs. The whole idea is that the master model is the highest level part that you derive all other files from. So the huge benefit here is the master model concept supports concurrent engineering. If you get your part file ready, drafters can start working on it, CAM programmers can start working on it, you can start doing analysis on your master model. The whole goal of master modeling is to do as much concurrent engineering as possible. You know, an unpacked definition, my version of it is basically, it's a file management strategy that you use during your design process. So again, a part master CAD model is shared between the drafting and manufacturing applications. So you would say that that CAD model is the part master. There are a few specific details about the master model technique. The most important thing is that the master CAD model drives the derivative files. The master model strategy is a one-way street with all major changes coming from the master. So if you change any of your derivative files, such as if you're making changes to your drawing or your CAM program, those won't feed back into the master model. You have to change everything from the master model and propagate everything down. So the idea is sort of this one-way editing approach. So, what are the benefits of doing this? This seems like a lot of sort of structure and strange effort, but what do you really get out of this? Like, why do you do master model? The biggest benefit in Siemens' definition is concurrent engineering. Multiple people can work on different things if you agree on certain features. So if you all agree that your master model is ready to be worked on, you can have drafters working on things, you can have programmers working on things, you can activate more people at the same time. It also is an approach that helps organize document control, adds clarity and priority to which files govern the final design. So you don't have to wonder if the drawing is the top level design or if the part file is the top level design. You arbitrarily decide, I have a master model, this controls the design. It helps control edits. It makes sure that master files and geometries are insulated from any sort of edits. So if you are a prototype programmer, you'll feel comfortable using this approach that you are creating the correct final geometry if you're programming parts and making prototypes. And also, if you're a proficient enough designer, you can take huge advantage of how parametric and associative NX is. So you can make very flexible models that update very easily if you set up your master models correctly. So you can change a dimension and have your drawing and CAM file update without any sort of major issues. So if you set up your master model structure correctly, you get a lot of time-saving benefits. So that being said, before we move along, this is sort of the benefit of master model. A lot of it comes down to concurrent engineering and document control. And so you don't spend a lot of time wondering which files you're trying to work with. We're going to jump away and start talking about wave linking right now. So that was our method. Now this wave linking is our tool. So wave linking is one of the greatest tools that NXCam programmers can use to make master model approaches significantly easier. It sounds like master model involves a lot of tough file management, revision control, but wave linking sort of simplifies that entire approach. So I make it a point to show off wave linking to anyone that doesn't use NX to make them super jealous. So what is wave linking? Wave linking is essentially a command that creates copies of geometry within NX. So you can copy from one part to another. So you can copy curves or edges. For example, if you want to, if you have a bearing and you would like to make a whole feature to capture a bearing, like a bearing block, you can basically parametrically size the hole in your bearing block to your bearing, and it allows you to share geometry across parts. If you select associative as you wavelink a solid body, any changes that you make to the original body will propagate to the linked body. So a wavelink makes a linked body. If you choose make position independent, you can move around your wavelength. But essentially what wavelinking does, and I'm about to show it to you, is it makes copies of geometry. So I'm going to open up NX and just show you a quick wavelink example. So right here, let's see. Here, all I've done ahead of time is I have a part file. This is going to sort of correspond to our part master model. What we're looking at right now is I essentially took a classic demo part from Siemens as a step file. I made a new model, and I imported a step file. So all we see on the part navigator is just that I imported a body, and this is it. And I've saved a part file with customer part number _ master. So part of our master model approach is this is going to be our master model. So we were talking about wavelinking and making copies. So what I'm going to try to do is I'm going to go to my assemblies tab right here, and then I'm going to click on wave geometry linker. And the goal is I want to make a copy of this solid body that's in exactly the same position. So I'm going to click on wave geometry linker. It says that I'm picking a type body. That's exactly what I want. I want to copy the entire body. You know, maybe for other situations, I might want to copy a curve or a sketch or a face. In this example, we're going to do bodies. And for the manufacturing approach, we're going to do bodies pretty much all the time. So if I try to click on this, part, nothing's happening. Like it's not highlighting red. It's not actually letting me do anything. The main reason is because we're actually in a part file, and wavelinker is an assembly feature. So as long as this is a single model, this isn't going to work. So what we need to do is we actually need to make an assembly with this part file. So that's what I'm going to do really quick. So I'm going to go to File, New. We're going to make an assembly. And we're going to call this, we're going to use a consistent file naming scheme. So we have customer part number _ master. So what I'm going to do is I'm going to call this one, I have to make sure I do assembly. We're going to call this customer part number. And I'm going to call this process master. And I'll be explaining this in a second. The folder for this one doesn't really matter too much. And we'd like to add a component. And so what I'm going to do is actually just click on Add. This is one way to do it. Loaded parts. Scroll down to, oh, here we go, customer part number master. And we want to get this part placed. Let's see. We'll click OK. We're going to fix constrain. So now we have an assembly with the part file in it. So now if we click Wave Geometry Linker, set ourselves to body, we can see that we can now highlight this. So again, we had to make an assembly because Wave Geometry Linker does not work in model files. We need to do it in assemblies. So when we click on this, we have some settings here. We want to keep it associative. That means if we change the original model, the copy will change as well. And we want to make our position dependent. So we want to keep this unselected. So if we move the original part file around, the wavelength copy will follow as well, because the position ends up being very important in manufacturing. So we very much care about that. So we're going to keep associative, and we're going to not keep position independent. So if we click OK, we now have a linked body in our part navigator. Let's see. So what I'm going to do to make this a little bit easier to track everything is I'm actually going to right click, or I'm actually going to click on the linked body, just select it, and I'm going to hit Control J, which is going to bring up some display settings. Edit object display is what comes up, and all I'm going to do is I'm going to change I'm going to change the color so we can very clearly tell which one's which. So I'm going to make the wavelength yellow. I'm also going to rename it, and I'm just going to call this wavelength copy. So again, we're just showing how to make copies of geometry. So you have to make an assembly with the part as a component, and then you're allowed to use wavelength. So if I hide the original solid body, we can see the yellow copy is here. If we hide the yellow copy and show the original, we can see it's still there. So we have a yellow wavelength and a gray regular copy. I'd like to sort of show the associativity. So what I'm going to do is, first I'm going to edit the original and show the associative relationship. So we're going to hide the wavelength and we're going to change the original. And all I'm going to do is I'm going to double click on the part so we can edit the part. Oh, okay, looks like I have to go back to the original because I have a units conflict. So back in the original part, all I'm going to do is go to home. I'm going to delete a face, and I'm just going to delete these top edge blends. I'm going to make the corner square. It's a pretty simple edit, very easy to notice. And if we go back to our original right here, if we go back to our wavelength assembly, we can see that change propagated into our assembly. And if we go look at our wavelength copy, and if we hide our original, we can see that the wavelength has taken on the edit that we've made to the original. So that's the associative relationship. If you change the original, the copy updates as well. So that being said, what if we want to change the wavelength? Should that change the original? So if we go and add an edge blend to our wavelength copy, I'm just gonna do one really quick here. So we've added a feature to our wavelength. Let's go back to our original. The original did not take on that change, and that's because the associativity is one way. So you can make edits to wavelengths that don't propagate back to the master, but you can make edits to the master that propagate back to the wavelength. So this one-way relationship for edits is a very important tool. So this way, your original file is insulated from any edits, but you can still make copies and edit on top of your original master model. So what I'm going to do is also kind of show you one thing, which is if we go back to the original, and if we delete this delete face feature, and if we basically put that edge blend back onto the part, we create a problem with our wavelength, which is that the edge blend no longer has the same edge to the edge blend no longer has an edge to reference to blend. So if you make changes to the master, you can affect your wavelength negatively. But the idea of this whole method and approach is that you're not making changes to your master. The master just sort of sits and hides in these processed master files. So the wavelength is a really important feature. You can make copies. You can make copies of copies. You can chain copies together. Extract body here is another way to make more copies. But the idea is you can copy solid bodies, make edits, and there's a one-way relationship for associativity. Let's see. Let's head back to the slides. Okay. So, this copy, is it a big deal? I truly think it's a big deal. The one-way relationship lets you sort of preserve the original geometry. So if you're a CAM programmer, you can basically keep your final geometry that you're trying to program to completely untouched. You can create a wavelength to your master, hide the original, make any modifications to your wavelength, and then verify your final programming against the original. So this sort of sets up a method for you to insulate your master model from any sort of changes. And so because we can do all these things, wavelinking is an excellent tool to actually execute the master model strategy. So the master model stays untouched. But let's sort of merge this all together. So like we've kind of talked about the method of master modeling. We've talked about the tool, the wavelinker. But we want to sort of show how you can actually use it within manufacturing. So from this point on, I'm actually going to show you an example of a file structure and approach where you use wavelength and master all together. We're going to establish a few process files. We're going to establish setup files. And so again, this is best practices. There are many ways to do this. So we're going to establish a master model. We're going to establish a master process file. And then we're going to show how these process files help create manufacturing setup files. And so the final goal is that you get to setup files and you're able to do very complex CAD edits without altering your final geometry in ways you can't track. So I'm going to hop back into NX, and we're going to stay with this part example. So we're going to say that our customer part number underscore master corresponds to a step file that we may have received from a customer. We're going to basically say that this is our master model. We have made no changes to it. I've imported a step file. One thing I might also do to set up my master model is to actually go to Home or File, Export, and you can export a healed geometry. So sometimes your model may have issues like small gaps or any sort of CAD import related issues. One thing you can do to establish a really nice master model is to heal your geometry and make that your first master model. In this case, we're going to not do that. But we basically have one file here. And my recommendation is that your master model is just the final geometry. So we didn't do anything to this. We didn't delete any features. We didn't modify anything. It is truly the part that we receive from the customer. So we're just going to click Save, and that's good. And we're going to do, to set up a master model technique, we're going to do the same exact thing. So we open up a new assembly. We open up a new assembly and place the part file within it. So at this point, we're going to create a process master. And for my approach, what I like to do for the process master is I like to make the process master the final geometry and the definition for the stock that we are going to use. So the context of all this is that we're going to do CAM programming on this part. So one thing I like to do to define stock material is I like to use the bounding body command, which is an excellent command for just really quickly. I use a search. It pops up right there under offset scale. And what we want to do is we basically want to create a block around our part. Oops. And so this is going to define the billet or the blank of material that we're going to use to machine our part. So this is the exact bounding block. So if we had the perfect size piece of material, this is what we start from. I'm going to add some offsets in all directions. So we have stock in every direction. This might be what we actually use. You want to use an oversized piece of stock. So we're going to click OK. And one thing to keep in mind is, if you want to do process control, tracking the dimensions of this bounding block is the stock and the blank that you use. So if you want to sort of build in some features to your master model system and you want to know what size blank you were using to make these parts, that information would be implicitly stored in your process master by just measuring the dimensions of this bounding block. So at this point, I would call this process master ready to go. You might want to also rename your bounding body, and you can just call it blank or stock or something like that. We're just going to call it blank and say, okay, this is good to go. So the reason we didn't make any wavelinks yet is because ultimately we're going to actually create wavelinks within our CAM setup file. We may find a need for simplified models, and so though we covered making wavelinks in the process master file, the approach that I'm going to show you actually involves making wavelinks in your setup file. So once we have our process master, this is the file that we want to program on. It's the final geometry, and it's the blank that we're going to make from it. So the reason we make this separate file is to define stock material, and also just in case the incoming customer part needs extra work or any sort of cleanup work, we like to sort of have just the standalone file that we're aiming to machine separately. So all we've done here is added a blank. So next thing I'm going to do is I'm going to make a new manufacturing file. Let's see, manufacturing, and I'm just going to do a general setup. And here it would be helpful to sort of have a consistent naming scheme. So what I'm going to do is I'm going to say we have the master file, the process master, and then I'm going to call this final one the manufacturing master. And then, it might be helpful to say which machine it's going into. I prefer to have each setup or each orientation for a part in a different manufacturing file. So sometimes it's worth it to say like setup 1, vertical mill, or like vertical 3-ax mill, depending on what you have. So we're going to create this file, and we're going to reference the process master file that we had open. Oh, okay. All right. That was interesting and new. I have not seen that one before. So what we're going to do is we're just going to go to a general. We're just going to go to a general setup. We'll give this a try. I have a units conflict. We can basically just, let's see. So I'm going to do a little cleanup. Okay, so now what we have here is our assembly, our process master file, which basically has a blank and it has the part. What we want to do really quickly is basically do any sort of positioning that we want. So if we want to constrain this into position on a vise or anything like that, we would do all constraints to the original part files because you cannot do constraints on wavelinks. So our plan here is we're going to constrain this into position, the original file, the process master. We're going to make wavelinks, and then we're going to start programming on top of the wavelinks. So because I don't have any sort of fixturing in here, there's nothing for me to really constrain to right now. But let's say, for the sake of this presentation, this part is now constrained in position, and we want to take it to the next step. Typically what we do is we wavelink the body that corresponds to the stock. And at this point, this is actually where the hide original checkbox is really convenient, because we want to make sure that we program on the wavelinks, not the original parts. So we want to hide the original as soon as we make a copy. So we wavelink the stock. So now it says linked body to blank, and we'd like to make another wavelink, which is the final geometry. And we'd also like to hide the original here. So this is us insulating ourselves from the edit. So if you remember from the last demo with the yellow part, we're hiding the original so that we can't make edits to our master model. So now what we have is we have the linked blank, and then we have, I'm going to call this, I like to call these final part. I like to leave no ambiguity. This is the final part. So at this point now what we have is, if we hide these, our original models aren't there anymore. They've been insulated. They still live in the same document, but we're no longer seeing them. And so at this point, we can go to our geometry view. We can set up our geometry tree structure. What I'm going to do is I'm actually going to put a blank out on front. I'll show you what I mean in a second. So the structure that we're going to do is we're going to have the blank at the highest level. We're going to specify just the linked body. For MCS, we're just going to leave it at some default location. That's sort of outside of the scope of what we're talking about. For workpiece, I'm going to specify the part itself. So I'm going to wait for that triple dot to appear. We're going to do quick pick, and we're going to pick the final part. So at this point, if we didn't need to do any sort of CAD simplification, we'd probably just hide the blank and start programming. We'd come into home, create some operations, create some tools, and just start doing programming. But if for whatever reason we wanted to make edits to this final part for programming reasons, to help things, for example, if your computer is not super fast and you need to hide some features to help generation move faster, we can start to sort of create simplified models that are completely associative to our linked bodies and thus our master model. So I'm going to show you how we can make a really easy version of this part in the same exact location with the same MCS without the top blend. So we're going to take off that top blend like we did earlier. So, we like this final part. We want to hang on to our final geometry. And so instead of making another wavelink, we're going to actually right click on our final part linked body, and we're going to click on extract body here. This is going to make essentially a copy of our copy. And we're going to rename this simple model. So we're going to hide the final part, and we're going to do some delete face on the simple model. And so remember, our goal is just to make a simplified model to help with toolpath generation, to help with CAM programming. So we can delete some faces, if we wanted to delete, if we want to delete more faces, or, this is really good for deleting holes. For example, if you want to use cavity mill and avoid certain features, you can just delete them. So if we hide the edited model and go back to our final part, those edge blends are still there. So we've only changed them on the simple model. But we're not programming with them just quite yet. We need to go back to our geometry tree and make one more workpiece. So we need to insert a geometry. We'll call this simple model. And then we'll specify and make sure that we pick the simple model. And so now if we wanted to do cavity mill and not notice those edge blends, we can just create an operation. We can go to mill contour, pick cavity mill. And now if we want to generate toolpaths based on that simple model, but sharing the same blank that we had earlier, we would just do toolpaths based on simple model instead of our workpiece, which is the workpiece is the final part geometry. And so the reason this is really helpful is because if you want to make alternative versions of the final geometry you're trying to program for, it takes a lot of assembly work, a lot of constraining and positioning and making sure that you've correctly established the associative relationships. With NX, it's very easy to just use the wave linker. The parts, because you've made the position dependent, are always on top of each other and share the same MCS for programming CAM operations. And they're associative to the original model. So if you make any edits to the original master model, your setup file always receives them. And if you make any edits to your simplified models, they are not propagated back to your original. So, we have this simple model here, but if we look back to the actual original file, it still has the edge blends, everything is fine, and we can evaluate the completion of our CAM program against this part without making any edits directly to the master file. And the reason this is helpful is because it basically helps with file management. You don't have to make a zillion different CAD files. Everything basically will live in your setup file or your process master. And for the most part, your master CAD model, this customer part number master up here, doesn't really change. As a prototype programmer, you might just sort of append master and save it as a .prt file. So let's see. I want to hop back to the slides for a second. So because this is best practices, so okay, we've done the master model, that was the original file, the customer part name, change the file name, place it in a directory. We've established the master process file where we create an assembly with the master model. We actually did not add a wave link, but we did add a stock body. And then in step 3, we established one setup file where we had the manufacturing process file with programmed operations, and we made simplified models. So we basically made 3 different files, although step 3, depending on how many setups you have or how many machining operations you do, step 3 could generate multiple files. So I want to sort of go over this on the general level. So your master model is the final geometry to manufacture. This is probably something that the customer emails from you, you get from Team Center, you get from some sort of like revision management database. This is essentially the final geometry, what you receive as a programmer. The first thing you set up is a master process file within the assembly application. You have to do the assembly application, otherwise WaveLink does not work, where you establish stock related information and any sort of cleaned up geometry. And by clean up, I sort of mean the heel or the optimized face or any sort of like CAD cleanup that results in you producing a CAD file that is the final geometry to machine. Then you take your master process file and use that across all your CAM setup files. And so all your CAM setup files have are the operations, the machine, the fixturing, any sort of simplified models. But any sort of extra CAD work you do happens in the CAM setup file. So the master process file is only the master plus the stock. The master model is just the master geometry. The CAM setup file is where everything happens. So, if you want sample file names, your master model in your modeling application might have like an xyz123.a.step. You change that to master.step or master.part. You bring that in and call it a process master in your assembly. And then you have a variety of manufacturing setup files. So we have at Applied a couple different machines. We have a DMU and we have a machine called Viper. So if you are programming a first setup in our 5-axis machine and then a second setup in our 3-axis machine, these are some of the file names you might use. And, down here at the bottom is sort of like a general file structure. So to bring it all back together, master modeling is basically a file management strategy. Wavelinking is a tool that you can use to sort of execute that strategy pretty easily within NX. And the thing that it enables you is basically you can create simplified models or modified models within a CAM setup without changing your master model very easily. So you click on Wavelink, you hide your original, you edit to your heart's content, and you make sure that you evaluate your CAM program against your master model, which always is living in your CAM setup file. This is a starting point. It's a guide. It's not like you're not doing master modeling if you're not doing this. This is one way to approach it. So thank you for your time. We will see you again soon.